Hello everyone. In this video, I'm going to quickly go over calculating the range of feasibility for our second binding constraint in the fertilizer example. In the previous video, I had already calculated the range of feasibility for the nitrate constraint. So now I'm going to do it for the ammonium constraint. I won't be going in quite as much detail. I just wanted to give you an extra example where we have to calculate that range of feasibility when one of our points is not at the axis, which will happen again here, and will pretty much happen anytime that we have more than two constraints in our model. The first thing I'm going to do for visual purposes is to get a line that overlaps that ammonium constraint that I can move around. So just inserting a line here. So there we go, something like that. And again, we've seen that what should happen is as I move the line one way, so say I move it up, once I move it one way, I'm going to eliminate one of the two current binding constraints. Again, I don't know which one that is right now, but say it eliminates nitrate. And then as I move it the other way down, it should eliminate the other current binding constraint. That's one nice double check I have to make sure that I do the work properly. The other thing we should see is that as I move it up, what should happen is really what we're doing is increasing the value of the right-hand side of that constraint. So that should give me the upper limit for my range of feasibility. And then as I move the constraint down, that should give me the lower limit and should give me a value lower than that value of 40. So hopefully those checks work out as we go through our math. Then after this, we'll do our ultimate check of where we're going to double check all this work with the use of Excel. I'm going to deal with the slightly easier one first. I'm going to move this line down to begin with because, again, I know what's going to happen here already. I'm going to move this down, and as I do so, envisioning what's happening as I move this line downwards, remember, as I move it down, what is happening right now, this whole line is moving and my feasible region is increasing. This would all now be part of my feasible region that is growing and growing and growing as I move the line downwards. And that region will continue to grow until I get to this point here, at which time my feasible region would now have grown to include all of this, at which point the ammonium constraint would have now left the feasible region. It would no longer continue to be a binding constraint. If it's not part of the feasible region, it cannot possibly be a binding constraint. So what we're going to find is as we move down, we are eliminating the ammonium constraint. And then as we reverse it and move it up, we should find that we're going to eliminate the nitrate constraint. Again, what I want to do is to find out what lines intersect at this point. And not the line that we're moving, because that's imaginary. That line isn't really moving. What we have here is the nitrate constraint is at that point, as well as the x-axis. So we are going to find the point at which those two lines intersect each other. So we find that the initial nitrate constraint, again disregarding the inequality, was 2a plus 3b is equal to 36, and the equation of the x-axis in this case is b is equal 0. So again, setting those equal to each other, I can simply sub in the b equals 0 into my opposite equation. So 2a plus 3 times 0 is equal to 36. Continuing on, 2a is equal to 36, or a is equal to 18. So now I have the 1 point here, which is my x-coordinate 18. The y-coordinate should be 0, which I can see it already is. But just to reinforce that it is, if I sub a is equal to 18 back into the equation, 2 times 18 plus 3b is equal to 36, or 36 plus 3b is equal to 36. I would end up with 3b equals 0 or b equals 0. So remember, that is only the value of the point of that intersection. To find out how that affects my range of feasibility, what I need to do is to sub those coordinates into the line that we are right now sort of playing around with. And what we are altering right now is our ammonium constraint. So this, because we are moving the line down, we are decreasing the y-intercept. This should give us the lower limit of the range of feasibility. And what I should find is subbing these values of 18 and 0 into that equation, I should get a value lower than 40. So subbing that in only to the left-hand side, 2 times 18 plus 5 times 0, we end up with a value of 36, which should be the lower limit for the range of feasibility of the ammonium constraint. So range of feasibility, I'll just short form that. For ammonium, I have a lower limit of 36. We now need to go and find the upper limit of that range of feasibility. So again, to find the range of feasibility or the upper limit of that range, I will now reset this line right back to where it was to begin with, right over top of the initial ammonium constraint. And now I will envision moving that line up the y-axis, increasing that y-intercept. And again, remembering what's happening now is now I'm eliminating this as part of the feasible region. I'm shrinking and shrinking and shrinking the feasible region now. And it will shrink as long as I keep moving this up. But as I keep moving it up, what I should find is that once I cross this intersection point right here, crossing that point, I have now eliminated nitrate as having any part of that feasible region. If I were to move the line up that far, nitrate has now been eliminated. And our check here did work out. As I moved up, I eliminated nitrate. As I moved down, I eliminated ammonium. Right? So one direction should eliminate one of the current binding constraints. The other direction should eliminate the other current binding constraint. And that's once again exactly what has happened here. So now all we have left to do is to calculate what is the value of this intersection point. And again, I'm not talking about with this line because that line doesn't really exist. That line exists down here. So currently the two lines intersecting there would be the phosphate constraint and the nitrate constraint. So I want to deal with the intersection point of those two constraint lines. So 5a plus 3b is equal to 45, and constraint 2, the nitrate constraint, 2a plus 3b is equal to 36. And again, remember, I can isolate for either variable in either equation. It doesn't matter which one. I'm going to choose to isolate for b in my first equation, which will give me eventually that b is equal to 45 minus 5a over 3, or that b is equal to 15 minus 5/3 a. So now with that, I will sub that into my other equation, right? If I isolate in one equation, I have to sub into the other. So now with 2a plus 3 times 15 minus 5/3 a equals 36. We end up with 2a plus 45 minus 5a is equal to 36, or that minus 3a is equal to minus 9, or a is equal to 3. Which again, if I look on my graph, does that agree with what the graph is telling me? Well, it looks like that pretty much hits at 3, but my math is telling me that that happens at exactly 3. So I'm feeling pretty confident about my calculation for A. So now what I need to do is to sub that back into one of my equations. I'll sub that back into the first equation. So subbing in A is equal to 3 into the phosphate equation, we end up with 5 times 3 plus 3B is equal to 45, or 15 plus 3B is equal to 45. 3B is equal to 30, or B is equal to 10. And once again, double check, does that seem to agree? And if I look visually, yes, it does look like it agrees with what I'm seeing on my graph. We now know that this point that we were interested in has the coordinates of 3 for X and 10 for the Y coordinate. Last but not least, remembering what line we are altering right now. We are dealing with the ammonium constraint. So we are going to sub those coordinates back into that constraint line. In just the left-hand side of that, 2 times 3 plus 5 times 10. 2 times 3, 6, plus 5 times 10, 50, or a final value of 56. So we now have our upper limit for the range of feasibility for ammonium. And once again, remembering what that is telling us. When we are looking for the range of feasibility, it is only the range for which the two binding constraints remain the binding constraints. Everything else in the model will change. The optimal solution will change. The maximum profit or minimum cost will change. The only thing that remains the same is the two binding constraints. With that done, all we have left to do is to hopefully use Excel to double check all that work, and hopefully we end up with the same ranges of feasibility for both the nitrate and the ammonium constraints, which we have just calculated by hand. Thank you. As always, please make sure you email me with any questions that you have.